Okay, so we have seen various number systems. So in this video, we will discuss about the possible number system conversions. That is, first we will see how a number in any number system can be converted to decimal number system. And second one, how a decimal number can be converted into any number system. And next category deals with the conversions between binary and other number systems. That is how you will convert a binary number to octal, octal to binary, binary to hexa, and hexa to binary. And the last category deals with conversions between hexadecimal and octal number system, hexa to octal and octal to hexa. So first we will discuss about how a number in any number system is converted into decimal number system. So the basic rule for converting a number n to base 10, the first step is multiply each bit of that number by its corresponding bit weighting factor. And second step is that you have to sum up all the products in step A to get the decimal number. That is, we know that every number of base n are positional or weighted number systems, which means that every digit in a positional number system will have a weight associated with it. So in order to find out the value corresponding to that number, you have to multiply the digits with its corresponding weight and then sum up all the products. That is, if you want to find out binary to decimal value, you have to multiply with powers of 2. If you want to convert octal to decimal, multiply with powers of 8. Hexadecimal to decimal, the base is 16, hence multiply with powers of 16. Then you have to add up the products. That is, in a positional number system, a number n is represented using n digits, then its positions ranges from 0 to n minus 1. That is, if I represent a number using 5 digits, then its positions ranges from 0 to 4. Okay, then how will you find out the value of that number in base R? You have to multiply every digits with corresponding weight positions. For example, if I want to convert this 11011 to the base 2 to its corresponding decimal value, you have to multiply every digit with its corresponding weight positions. That is what is done here. That is D0 into R raised to 0. R raised to 0 is 1, hence it is D0 itself, plus D1 into R raised to 1, that is R. So D1 into R. Next will be D2, that is digit at position 2 into R raised to 2. Next digit at position 3. So it is D3 into R raised to 3. Multiplied etc. up to digit at position n minus 2 multiplied with R raised to n minus 2 plus digit at n minus 1 multiplied with R raised to n minus 1. Hence here, as per the formula, you can represent as D0 itself. So 1 plus next one is 1 into your R is 2 here. So 1 into 2, because R raised to 1 is 2 itself. 2 raised to 1 is 2 itself. Next is 0 into 2, 2 raised to 2, because your weight is 2 raised to 2, that is 2, plus 1 into 2 raised to 3 plus 1 into 2 raised to 4. Okay, that is your positions ranges from 0 to n minus 1, 0 to 4. So multiplying and adding up the products, you will get the corresponding decimal value of this binary number. So 11011 is nothing but 27. Now how will you convert this octal number? This octal number is represented using 4 digits, hence its positions ranges from 0 to 3. So these are the powers which has to be given for the base 8, which has to be multiplied with every bits to get the corresponding value. So 7 into 8 raised to 0 plus 0 into 8 raised to 1 plus 1 into 8 raised to 2 plus 2 into 8 raised to 3, which will yield you 1095. Okay, so first we will discuss with how you will convert a binary to decimal. We will see more examples of this step, binary to decimal. So binary to decimal, the steps as we have told earlier, you have to multiply with powers of 2. Why? Because the base is 2 for binary. And then you have to add up the products. So we know that these are the weight positions for binary number system. Towards left from the binary point, the powers are increasing order. 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. So this has got the weight. 2 raised to 0 is 1. 2 raised to 1, it is 2. 2 raised to 2, it has got the weight 4. 2 raised to 3, it has got the weight 8. Similarly, after decimal point, the powers are in the decreasing order. 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3, etc. Okay, so let's see one example. So how will you convert this 1101.1011? You have to multiply with corresponding weights. So how will you calculate this? 1 into 2 raised to 0 plus 0 into 2 raised to 1 plus 1 into 2 raised to 2 plus 1 into 2 raised to 3 plus 1 into 2 raised to minus 1 plus 0 into 2 raised to minus 2 plus 1 into 2 raised to minus 3 plus 1 into 2 raised to minus 4. Adding up all the products, you will get 8. 1 to 2 raised to 2, it is 4. So this becomes 0. So 8 plus 4 plus 0 plus this becomes 1. Then add with 0.5 plus 0 plus 0.125 plus 0.0625, which will yield you 13.6875 to the base 10. Okay, yes. Some more examples. How will you calculate the corresponding decimal value for this binary number 11001? So this has got the weight 2 raised to 0. This is 2 raised to 1. This is 2 raised to 2. This is 2 raised to 3. And the last bit portion, that is the most significant bit portion, has got the weight 2 raised to 4. Isn't it? So how will you find out the corresponding decimal value? 1 into 2 raised to 0, that is 1, plus 0 into 2 raised to 1, that is 0. 0 into 2 raised to 2, that is 0 into 4, that is 0. Then 1 into 2 raised to 3, that is 1 into 8, that is equal to 8. Then 1 into 2 raised to 4, that is 1 to 16, is equal to 16. So you can add up 1 plus 0 plus 0 plus 8 plus 16, which is equal to 25. Now, how will you find out the decimal equivalent for the fractional part? You have to multiply with negative powers of 2. So this has got the weight 2 raised to minus 1. This portion has got the weight 2 raised to minus 1. This portion 2 raised to minus 2, 2 raised to minus 3, 2 raised to minus 4. So 1 into 2 raised to minus 1, which give you 0.5. This is 0 into 2 raised to minus 2, which is equal to 0. Then 1 into 2 raised to minus 3 is equal to 0.125. And this is 1 into 2 raised to minus 4, which is equal to 0.0625. Adding up, you will get 0.6875 to the base 10. Now, looking closely to these conversions, it is very clear that you don't need to do this 0-bit portions with multiplied with its weight. Why? Because 0 multiplied with any number will give you 0 only. So how can you calculate the decimal equivalent of a binary number in shortcut method? You need to multiply the bit portions with weight having positions one value. That is, you need to multiply the positions which occupied with 1. So you need to add only 1 into 2 raised to 4 plus 1 into 2 raised to 3 plus 1 into 2 raised to 0. Isn't it? 1 plus 8 plus 16. Similarly, here also you need to add only these positions. 1 into 2 raised to minus 1 plus 1 into 2 raised to minus 3 plus, because this is 2 raised to minus 2, this is 2 raised to minus 3. 1 into 2 raised to minus 3 plus 1 into 2 raised to minus 4. Okay, so this is called as sum of weights method. We will see sum of weights method in detail now. Yes, sum of weights method. So in sum of weights method, we will be representing the weights. And in order to find out the decimal value, just represent that number under the corresponding portions in that number system. That is, in order to calculate the decimal value of binary number 0, the 0 occupies only one bit. So which portion it will occupy? This portion, because this has the weight 2 raised to 0. 2 raised to 0 is 1. This is 2 raised to 1. This is 2 raised to 2. This is 2 raised to 3. These are the bit portions. After decimal point, this is 2 raised to minus 1. That is 0.5. 2 raised to minus 1. This is 2 raised to minus 2. Yes. So 0, since it is one digit, it occupies the bit portion 2 raised to 0. Isn't it? So as I told you earlier, you need to add up the weights which yield you one in the bit portions. Here there is no 1 in the bit portions, hence the result is 0 itself. So 0 in binary is equivalent to 0 in decimal also. Okay, so how will you convert this 1 in binary to decimal? You'll be representing 1 at the bit portion 1, 2 raised to 0, because only one digit 1. Since this position has got the value 1, you will be adding up this 1. Okay, so there is no remaining portions which has to be added up, because the remaining portions are 0. Nothing is there which occupies portion value 1, bit value as 1. Hence you need to add only 1. So answer is 1. So 1 to the base 2 is equal to 1 to the base 10. What about 1 to the base 2? So 1 to the base 2, when you represent in 8421.5.25 format, that is in the this format, what you will get is this portion has got the value 1. This weight portion also has got the value 1. So you need to add up these two weights. So 2 plus 1. 2 plus 1 is 3, because we know that 1 can be calculated as 1 into 2 raised to 0 plus 1 into 2 raised to 1. It is nothing but 1 into 2 raised to 0 is 1 itself. 1 into 2 raised to 1, it is 2. Okay, the shortcut method is just add the weights that give you the value as 1, bit portions as 1. So 2 plus 1 is 3. Similarly, how will you find out the corresponding decimal equivalent of 110101.11? Represent the numbers. Here you require how many digits? Towards left, 6 digits. So 2 raised to 0, that is 1. 2 raised to 1, 2. 2 raised to 2, 4. 2 raised to 3, 8. 2 raised to 5, 16. So 2 raised to 4, 16. 2 raised to 5, 32. Towards right, 2 raised to minus 1, 0.5. 2 raised to minus 2, 0.25. Now represent the numbers. And take only the weights. You need to add only the weights that give you the bit value as 1. So here the bit value is 1, so add up 32. Here the bit value is 1, hence you have to add 16. Here the bit value is 0, so don't take 8. Here the bit value is 1, so add up the weight 4. Here the bit value is 1, hence add up the weight 1. Here the bit value is 1, so add up 0.5, also 0.25. So 32 plus 16 plus 4 plus 1 plus 0.5 plus 0.25 is equal to 53.75 to the base 10. Okay. Now moving to next slide. So this is, I have represented the conversion table of decimal to binary value. The decimal numbers from 0 to 15 and its corresponding binary value. Okay. So this is the binary equivalent of 0 represented using how many bits? 4 bits. If you represent a number 0 using 1 bit, you can represent as 0. If you represent 0 using 2 bits, it is 0, 0. If you represent using 3 bits, it is 0, 0, 0.